Okay, can everyone see all right?
Yep.
Yep. Okay. All right, so the slope of the tangent formulas. And we're going to look at a formula for finding the slope of the tangent at a specific point, and then also just at a general point in terms of x. So our learning goals are learning to find the slope of the tangent at a specific point using the slope of the tangent formula, also called the first principles formula. And that is what our assignment is on today. So it's on using these two first principles formulas. So yesterday was kind of just an introduction, the way Newton first developed calculus, and then it was further developed into using these first principles formulas. And that's what we're going to do today. All right, so mathematicians notice that finding the slope of the tangent to a curve at a specific point always involve the same set of 3 steps. First, you make your points P and Q, and then you find the slope of the secant that joins P and Q, and then you take the limit as h approaches 0 of the slope of the secant to get the slope of the tangent. Okay, and whenever mathematicians see that the same procedure is used over and over again, they see that they could generalize that into often a formula. So the process of finding the slope of the tangent to the curve y equals f at x, so that's any function at a specific point a, so a would be a number, okay? And then f at a would be the value of the function at that number. So this could be like a 0.24 or something, okay? It can be generalized to the following formula. So the slope of the tangent is equal to the limit as h approaches 0 of f at a plus h minus f at a over h. And I'm going to, up here, show you why that is true, okay? So if we look at our 3 steps again, our point P is going to be some number a, and then the value of the function at a. And then our point Q, so this would be kind of like our first step from yesterday. Your point Q is going to be a little bit to the right of A, so it's going to be A plus H. And then the corresponding Y value is going to be the value of the function F at A plus H. And then if we want the slope of the secant, we would label our points and find the slope of the secant using the slope formula. So y2 is this f at a plus h minus y1, which is f at a, over x2, which is a plus h, minus x1, which is a. And you can see what happens is you've got in the denominator here a minus a, which goes away to, adds up to 0, leaving just h in the denominator. And then step 3 is that the slope of the tangent is equal to the limit as h approaches 0 of the slope of the secant. And that's how they ended up with this formula here, okay? And I guess the big difference when we're using the slope of the tangent formula for us today is going to be that we're going to do all this simplifying of the slope of the secant, which really this part here represents the slope of the secant. We're going to do all that simplifying to be able to divide out that problematic h so that we can let h approach 0 within all our steps in the formula. And we're not going to, and then we'll at the end take the limit. So the limit will travel down with us until we've been able to divide out that problematic h. So that's how the formula came to be. It's pretty straightforward. But along with the formula came some new, less arduous. Arduous means like cumbersome, like a lot of trouble to write it out. So rather than writing m with a subscript tangent every time, they came up with some new notation. And this also says this, if I'm thinking to myself how to say that, I say f prime at a, but really it means the slope of the tangent to the curve when x equals a. Okay, so it still means slope of the tangent. It's just quicker to write f prime at a. But that's how you say it in your mind, f prime at a, but you're thinking, okay, that also means the slope of the tangent. It also means that we could start thinking of the slope of the tangent to a curve at a specific point as the derivative at the specific point. So derivative is another word for that idea of the slope of the tangent, which is, again, shorter idea of saying. So then we have the second formula that is exactly the same as the first, except we changed f prime at a and slope of the tangent. And either one is fine to use. The big thing here is that you know that they both mean the same thing. Okay. All right. So use the formula to find the slope of the tangent to the curve, y equals negative x squared plus 4x plus 1 at the point 3, 4. All right. So we've got our slope of the tangent formula. And since they write slope of the tangent here, I'm just going to write out, I'm going to pick the first choice here and ease our way in. So m tangent is the limit as h approaches 0. So this is our first principles formula. And for now, I'm going to just write the formula while we get used to it. F at a plus h minus f at a over h. So I've just written the formula out. Now for this formula and for this specific question, does anyone think that they know what A is?
3.
Yes, good. So this is our A here, and this is our F at A, 4. Okay. And if I wasn't sure, I could find F at 3 using this defining equation here and make sure that it's 4. And that will give me 4. Okay, so we do know A and F at A, so that's good. So I can rewrite this now. So the limit as h approaches 0 of f at 3 plus h, because A is 3, minus f at 3 over h. And you could definitely start at this step here. If you know that A is 3, rather than rewriting the formula, you could start here, okay, with m tangent equals the limit as h approaches 0 of f at 3 plus h minus f at 3 over h. All right, so we know f at 3. We now need to find f at 3 plus h. So that's going to take a little more intense algebra. So again, we're going to use our defining equation here. Replace x with 3 plus h using brackets. And this is really where any little mistakes can be made, I find, is the most common point to make a mistake here. So be careful with it. I'm going to write this out twice again. If you're good at squaring binomials in your head, then go ahead and do that. So again, remember from yesterday that I'm going to expand these by multiplying each term in the first binomial by each in the second. And then I'm going to simplify inside the brackets here. And then distribute the negative sign through every term in the bracket. And then collect like terms. So I've got -9, +12 is 3, plus 1 is 4. -6h plus 4h is -2h. And that's everything except my -h². So that's f at 3 plus h. So now I'm going to come back to my formula. And I can replace f at 3 plus h with 4 minus 2h minus h². Okay? Then there's a minus sign in my formula. And then f at 3 is 4 over h. Okay, so again, this is f at 3 plus h. So I replaced f at 3 plus h with this. F at 3 is 4. So I replaced f at 3 with 4. And then there's a subtraction in the formula because it really represents the slope of the secant there. So this is y2 minus y1. And we know x2 minus x1 always turns out to be h. Okay, so now look in the numerator and see if you can simplify. So we've got 4 and -4 are a 0 pair. So we're left with -2h minus h² over h. Then we want to common factor h out of the numerator. So that we can let h approach 0. So we can do that now. Divide those out. Now it's okay to let h approach 0 because the denominator is really, we don't see it, but it's a 1. Okay, so it's not affected by letting h approach 0. As we let h approach 0, -2 minus h approaches -2. So then I go back over here. Therefore, my 3 little dots, m tangent equals -2. Okay, so that means the slope of the tangent to that curve at the point 3, 4 would be -2. Everybody good for that one?
Ms. Northwood,
Yep.
do you have to show the step where you factor out the h?
So you want to go right from here to here?
Yeah.
Nope, you have to show that step.
Okay.
Thanks for asking. All right, any other questions for this one?
Can I just have a second to get this down?
Oh yeah, sure. While you're doing that, I'm just gonna grab my. Do you guys know how to use Desmos?
Yep. Yes.
Most people. So if you use it, I'll put it under here in a second, but I could type in this function. And see it there. Okay, so I've typed it in and I can see it there. And the point I'm looking at is the point 3, 4, which is here. So I can see that I expect to get a negative slope of the tangent. And if I go down 2 over 1, looks like that would be the slope of the tangent. Okay, so Desmos is a good tool for if you're not sure whether your answer makes sense or not. Are we good to move on?
I just have one more question
Yep.
about when we did f at 3 plus h. Why? Oh, never mind. I figured it out.
You figured it out?
Yeah, I'm good.
Okay, great. All right, the next one. Given f at x equals the root of 2x minus 1, find f prime at 13 and explain its meaning. Okay, so instead of asking us for the slope of the tangent, they're asking for f prime at 13, but what you should be thinking to yourself is this means you want the slope of the tangent to f at x equals the root of 2x minus 1 at the point where x equals 13. So that's what that question's asking for. Okay, so your brain is saying f prime at 13. I want to know the slope of the tangent to that curve when x is 13. Okay? So I'm going to choose to use this formula that already has f prime at a number in it. Okay? So I'm going to do f prime at 13 equals the limit as h approaches 0 of f at, and since a is 13, so instead of a plus h, I'm going to write 13, f at 13 plus h minus f at 13 over h. So I'm just following this formula exactly how it looks, but I'm replacing each a with the number 13. Because a represents the number that that x equals. Everybody okay there? Okay, so now we actually have to, at the side here, figure out what is f at 13 plus h. So we take our defining function and we find what is f at 13 plus h. So it's the root of 2 times 13 plus h minus 1. And I want to simplify that at least as much as I can. So I can multiply the 2 through and get 26 plus 2h minus 1. And then I can combine the 26 and the minus 1 and get the root of 25 plus 2h. And that's the best I can do. And then I also need to find, according to my formula, f at 13. So I'm again going to use my defining equation, replace x with 13. And I end up getting the square root of 25, but I know that the square root of 25 is 5. So now I can go back to my formula and replace f at 13 plus h with the square root of 25 plus 2h. And then minus f at 13 is 5 over h. And again, I'll show this correspondence here. So f at 13 plus h is the square root of 25 plus 2h. F at 13 ends up being 5. And that's all we've done there between the first and second step, but it took us all this kind of side work in order to figure those out. Everybody okay so far?
Yep.
Okay, so my issue is I can't let h approach 0 because then the denominator is approaching 0, and I can't have that happen because division by 0 is not defined. So I have to figure out a way to free up this h under here, and we're going to do the same thing we did yesterday, which is multiplying top and bottom by the conjugate radical. So does anyone think they know what the conjugate radical of the numerator would be?
I think I do.
Okay, tell me.
Square root of 25 plus 2h and then
Yeah.
plus 5.
Yes, very good. So exactly the same under the square root sign, exactly the same at the other end, opposite sign in the middle. So it sets up, someone said yesterday, like a difference of squares pattern, and that's totally true. Awesome. And whatever you do to the top, you have to do to the bottom so that you keep the fraction the same. Great. So then on our next step through, we're actually going to multiply using FOIL the two conjugate radicals together in the numerator. So we get all that nice canceling happening. So first we're going to multiply the square root of 25 plus 2h by itself. Remember from yesterday, if we multiply, you don't have to write this down, but if you multiply a root by itself, it's the same as having that square root squared, and square undoes square root. So when you multiply these first two together, you just end up with, don't forget to write your limit down, that's an occupational hazard in calculus. You just end up getting 25 plus 2h. Squared undoes the square root. So there's your first multiplication. Your second one would be the root of 25 plus 2h times positive 5. And that's just going to give you plus 5 root of 25 plus 2h. Your third multiplication is going to be doing the negative 5 times the root of 25 plus 2h, so minus 5 root of 25 plus 2h. And then your fourth multiplication is going to be the minus 5 times the plus 5, which is minus 25. And then that's going to be over h times, so we'll use a bracket for multiplied by, root of 25 plus 2h plus 5. Okay, once you've done that, you're going to look in the numerator and see where you have 0 pairs. So you should see you've got a 25 and a negative 25 that add up to 0. You've got this plus 5 root 25 plus 2h minus 5 root 25 plus 2h. So they add up to 0.
Do we have to show that full step every time, or can we just put the 2h on the top?
You need to show this first step definitely today. Once we start doing just limits for the sake of limits tomorrow, we can go, I'll show you what you need to show, okay?
Okay, thank you.
Because part of it is I have to make sure you know how to multiply the binomials together. Like that's a course expectation. But tomorrow when we just focus on limits, I'm hoping that everyone's going to get the hang of what happens when you do this. And some people already have, which is great. Okay, so what we're left with on the top is our 2h. And on the bottom, we have the h times the root of 25 plus 2h plus 5. And again, I can't let h approach 0 until this h, this free h in the bottom is how we've gotten rid of it somehow. So in this case, we can divide top and bottom by h, or we can divide these h's out, leaving me with 2 on top. Okay, so once you've got it to that step, you should see that now it's safe to let h approach 0 because the denominator does not approach 0. So now you can go ahead and take the limit as h approaches 0. So we don't need to write limit anymore because we're now taking the limit. So we're going to have 2 over, so the root of 25 plus 2h as h approaches 0, that's just going to approach the square root of 25. And then I still have my plus 5. And if I keep going, that's going to be 2 over 5 plus 5, which is 10. And then that reduces to 1/5. Because you can divide top and bottom by 2. Okay, so we found f prime at 13, which is what it asked us to do. And then it said explain its meaning. Anyone think they can explain the meaning? What does that mean? No?
The slope
Okay,
of
so,
the
yeah,
the
go
slope
ahead.
of the tangent at f prime 13 is 1/5.
Close. The slope of the tangent to the curve
Ah,
f at x equals the square root of 2x minus 1. The slope of the tangent to the curve f at x equals the square root of 2x minus 1 at the point where x equals 13 is 1/5. So this represents the slope, and this is where. Okay? Any questions for that one? If we have some people still copying, I'm just going to put this one onto our onto the Desmo so you can see it as well. So if you look at this one, the point where x is 13 is right here. So there at 13.5, there's my point. And then my slope is positive 1/5, which would mean go over 1, 2, 3, 4, 5, and up 1. So it's going to be a nice gentle slope. The tangent and positive makes sense. Is everyone okay if we move to the next question?
I just need to get the therefore statement down.
Okay. Also, just for you guys, I will take pictures of these and post the lesson notes in case you miss something and you look back at your notes and you think, oh, how did I get from this step to this step? You can go back and look at our version we did together. All right, if we look at question 3, find the equation, oops, it's not even there. Find the equation of the tangent line. So this is a bit different, and be careful with this. When you're asked for the equation of a tangent line, you're not just asked for the slope of the tangent, you actually are asked for the equation of the tangent line, which we normally answer in y equals mx plus b form, okay? So your answer is going to be an equation rather than just a number when they ask for the slope. To the curve f at x equals 3 over 5 minus x, which they show here, at the point p 1/3 in standard form. So basically that's going to involve us finding it first in y equals mx plus b form and then changing it into standard form, which we learned how to do in, I think, grade 10, but I'll go over it again. It's not too bad. All right, so we're finding the slope of the tangent at a point. So I would probably start off with my slope of a tangent formula, which is this one here. So I'm using this one. And my A is 1, okay? This is going to be my A. So I would start off saying the slope of the tangent is equal to the limit as h approaches 0 of f at 1 plus h minus f at 1 over h. And then I have to figure these things out. So I know f at 1, I'm going to believe this point, which I have no reason not to. F at 1 is 3/4. If I wanted to test it out, I could come over here. F at 1 is 3 over 5 minus 1, which is indeed 3/4. We can look on our graph. 1 3/4 looks like our point P is right there. So we'd be expecting a positive slope of our tangent, not very steep. And then we also want to find f at 1 plus h. I'm going to go below here. It's going to be using my defining equation, 3 over 5 minus, so be careful here. We're going to replace x with 1 plus h, so we need brackets because of that negative sign especially. And then you want to distribute that negative through. So it's going to be 5 minus 1 minus h. Another place where you could get mixed up, if you only distribute the negative with the 1 and not the h, you'll get the wrong sign in front of the h, which is problematic when you're trying to get the correct slope. Okay, so I feel like that's as good as we can get for that one. Once we've got them, we're going to go back to our slope of the tangent formula and substitute them in. So the slope of the tangent is equal to the limit as h approaches 0 of 3 over 4 minus h minus 3 over 4 over h. So I've got this 3-layer fraction that I have to simplify. So I'm going to look in the numerator and see what there is to do there, and there's a subtraction. How do I subtract fractions?
Common denominator.
Common denominator, good. So here's one of my denominators, and here's the other one. Who thinks they know what the common denominator is?
Would it be 4 bracket 4 minus h?
It sure would. Okay, so always multiplying for common denominator. So it's going to be 4 times 4 minus h. So I'm making each of these fractions in the numerator out of the denominator 4 times 4 minus h. And then you have to adjust the numerators accordingly. So to get from this denominator to this one, I had to multiply by 4. So I have to multiply the top by 4, and 3 times 4 is 12. To get from the denominator 4 to 4 times 4 minus h, I had to multiply by 4 minus h. So I'm going to write it like this, 3 times 4 minus h. And that's still all over h. Often people forget about that. They get so concerned about simplifying the top that they forget that over h, which is actually very important. That's what you're doing all this algebra to divide out, hopes of dividing out. Okay, so don't forget your limit. The next thing I'm going to do is, now that I have a common denominator in the numerator, I can, in this case, subtract the numerators over the common denominator. And just so I get signs right, I always like to write out this step here before I distribute. And then at the same time, I like to take care of this divide. So again, similar to yesterday, dividing by h over 1 is the same as multiplying by 1 over h, which is going to allow me to just have a 2-layer fraction going forward. So don't forget your limit. Now, multiplying by 1 doesn't do anything, so I'm just going to continue to simplify the numerator here by multiplying the -3, or distributing it through the bracket there. So my numerator is going to become 12 minus 12 plus 3h. Because a -3 times -h is positive 3h. And in the bottom, I'm going to take this monomial term 4 and multiply it by the h. They're both just monomials. I've got 3 things multiplying together, the 4 minus h, and the h, and I can take the 4 and the h and multiply them together. So that's going to give me a denominator that's 4h times 4 minus h. And I don't want to distribute in the bottom because I want to keep this h as free as possible, because that's my problematic one. That's the one that's going to force the bottom to become 0 as h approaches 0. The one that I'm hoping to divide out. So if you look at your numerator now, we get lucky because 12 minus 12 is a 0 pair. So you're just left with 3h in the numerator. And in the denominator, we've got 4h times 4 minus h. So now I've got it to where I can divide out these h's. So 3 times h over 4 times h. We can divide the h's out. Oops. And you can always test before you go ahead and let h approach 0. You can say, what would happen if I did? The 4 would be fine. 4 minus h would approach 4, so I'm good. So I can now take the limit. So as I take the limit, as h approaches 0, the 3 is going to stay the same. The 4 is going to stay the same. 4 minus h is going to approach 4. So therefore, the slope of my tangent is going to turn out to be 3/16. So positive, which we thought when we looked at our picture, and not very steep. 3/16 isn't very steep. So our slope of our tangent makes sense. But if you remember back to what the question asked, it doesn't just want the slope, it wants the equation of the tangent line. Not only that, it wants it in a certain form. So we've done all the calculus now. You've got the slope of the tangent, that's the calculus. Now we're kind of reviewing some grade 9 algebra, grade 9 and 10 algebra. So we want the equation of the tangent line. So here's our slope. We also have a point on our tangent line, and that happens to be point P, which we were actually given in the question way up at the start. Point P was 1 3/4. And we know that that point is on our tangent line. It's the only point that our curve and our tangent line have in common. So this is our X and our Y, and this is our M. So if we go back to like grade 9 math, we would write out Y equals MX plus B. And B would be our Y-intercept, which is unknown, and that's what we would solve for. So we can replace Y with 3/4, M with 3/16, X with 1, and B is our unknown. And we want to get B by itself. So there's a couple ways we could go now. Do you want to clear the fractions, or do you just want to subtract fractions?
Subtract fractions.
Subtract fractions. Okay, so we're going to subtract 3/16 on both sides, which is going to lead us to B being 3/4 minus 3/16, which we need a common denominator for. So 16 is going to be our common denominator. And we had to multiply the bottom by 4, so we have to multiply the top by 4. So we get that B is 9/16. So that leads us to knowing that Y equals 3/16 X plus 9/16 is the equation of our tangent line. Okay, Y equals MX plus B. M is 3/16, B is 9/16. But the question wants us to answer in standard form, which is another form of the equation of a line. Okay, and the thing about this form of the equation of the line, actually we'll learn about how significant it is when we get to vectors actually, but there's A always has to be a positive whole number. And you'll see often a textbook asking you to answer in standard form, especially when there's a lot of fractions here. It looks prettier in standard form because A ends up having to be a positive whole number. So basically we're just using algebraic manipulation to go from Y equals MX plus B and then put it in this form. Okay, so the first thing I do is I look and see whether X, the number in front of X is positive. It is. Okay, so I'm going to bring everything to the one side. But before I do that, I want to, knowing this has to be a positive whole number, I'm going to multiply every single term by 16, our common denominator. So if I multiply both sides by 16, it's the same as multiplying every single term by 16. And you can see that I don't have fractions anymore. And then I'm going to, A has to be a positive whole number, which it is. So I'm going to subtract 16y from both sides. And I'll fit it in so it looks like this pattern here. So I've got my 3x minus 16y plus 9. And then my therefore statement. Therefore, the equation of a tangent line is, and I'll just put I'll switch sides here. So 3x minus 16y plus 9 equals 0. Any questions on how to get the equation of the tangent line in y equals mx plus b? So in this one right here first, I'll ask. Any questions for that? The main things to remember is once you get your slope of your tangent, that's your m, and your point is your x and y, and then you can use algebra to get b. And then you just have to use algebra to, if it asks you to put it in standard form. Often it'll just ask for y. Hi, my power went off. Did anyone else's power go off?
Don't
No?
think so.
Okay, my power went off, so I'm going to stop recording this and then start a new recording. I'm using my phone as a hotspot right now, okay? So that'll, hopefully what we've done will save, I'm hoping.